rebuild the scene, then relight it. A team from Tübingen, ETH Zurich, and Google teach a feed-forward network to look at a few posed photos of a room and, in a single forward pass, predict a full three-dimensional Gaussian splat of that scene, where every point carries not just color but a physical material, albedo, metallic, roughness, plus a surface normal. Move the light and the scene re-renders correctly. It is the first method that is simultaneously feed-forward fast, multi-view consistent, and relightable. The forward pass. Feed in N posed images and their camera matrices. The geometry branch, a ReSplat style encoder, builds a multi-view cost volume from depth candidates. The intrinsic branch runs frozen DINOV2 patches through a 36-block transformer that translates features across views. 6 heads decode depth, rotation, scale, opacity, albedo, metallic, roughness, and normal. Unproject the depth to Gaussian centers, each point inheriting its pixels material. 1 rasterization pass emits albedo, metallic, roughness, normal, and depth maps. Geometry and material, jointly, in 1 pass. The gap it fills. 3 axes have traded off for years. Per scene optimization is consistent and relightable, but slow, hours per scene. 2-dimensional image. Space learners are fast, but their predictions drift between views. Feed-forward 3-dimensional RGB methods, like PixelSplat and InvSplat and ReSplat, are fast and consistent, but they bake color into the geometry as spherical harmonics, so you cannot relight them. No method was all 3. InvSplat is the first row in the table that is feed-forward, multi-view consistent, and relightable at once. The real win is consistency, on table 3. Reprojection error measures whether material predictions agree when you warp them between views. On metallic, InvSplat hits 0.041 versus 0.051 for the fine-tuned baseline and 0.056 for the original. On roughness, 0.025 versus 0.034 and 0.038, lowest in both. The explicit 3-dimensional representation is doing the work, because every view reads from the same Gaussians. Now, the honest counterpoint on table 2. Raw reconstruction quality, pixel for pixel on the INPA views, InvSplat does not win. Albedo peak signal to noise is 22.18, and the fine-tuned 2-dimensional baseline edges it at 22.92. InvSplat is actually worse on all 7 reconstruction cells. The contribution is not sharper pixels. It is the 3-dimensional, relightable, multi-view consistent representation you get alongside comparable quality. Here is the payoff you can see. Before, a warmly lit interior, lamp glow pooling on the floor, soft shadows from the window. After, the same geometry relit, a cool directional light raking across the wall, the surfaces responding through their stored materials, the metallic ones shinier, the rough matte ones holding. The Gaussians did not change, only the light did. That is exactly what baking color into splats could never do. The architecture earns its keep, on table 4. Stack the 2 baselines naively, MV inverse for materials plus ReSplat for geometry, and you carry 2 backbones. InvSplat unifies them, sharing features across both branches, and beats the naive stack on 6 of 7 material metrics, albedo, metallic, roughness, and normal. The one tie is albedo structural similarity. Same job, fewer parameters, 1 forward pass. 5 honest caveats. First, reconstruction quality slightly regresses versus a fine-tuned 2-dimensional baseline, so the win is consistency and relightability, not sharper pixels. Second, the consistency gain is metallic and roughness carried on albedo reprojection InvSplat is marginally worse. Third, novel view synthesis and relighting are shown qualitatively in figures, with no quantitative novel view metrics. Fourth, no per-scene optimization baseline was included, so there is no head-to-head against the strongest conceptual competitors. Fifth, no seeds or confidence intervals and several decisive deltas sit below 0.01. Cite the representation, not a deployed product. Rebuild the scene, then relight it. InvSplat is the first feed-forward model that predicts physically based, intrinsic material, 3-dimensional Gaussians from posed photos in 1 pass, winning on multi-view consistency while honestly conceding a slight raw quality regression and figure-only relighting results. Subscribe for the next breakdown.